we are studying the nature of the roots and also relationships. And now today's we will study relationships between the discriminant and discriminant and nature of the roots. So relationship between the discriminant and nature of the roots we will study here. So what is relations? So by the quadratic formulas we know that by the quadratic formula we know that the formulas that a standard form of the formula ax square bx plus c is equal to 0, where we can say that that d is equal to under root 4 b square minus 4 ac is a discriminant. So d is equal to b square minus 4 ac. Okay, so here is the d discriminant. If the discriminant is given here, so three conditions arises in these equations: first, second, and third conditions. First, second, and third conditions, reals, roots will be reals, and the roots will be reals and naturals. And third conditions will always be say that the root cannot be exist, or it would be as imaginary if may be possible. Okay, so real roots cannot be possible in third states if the discriminant is is less than 0, and if the discriminant is more than 0, then root will be always be reals. Okay, so and if the discriminant is less than 0, sorry, discriminant is in a minus or negatives, so roots will always be unnatural and sorry it will be reals and exist. Okay, so here's three conditions. With the help of these three conditions we will discuss here and try to find out the understand between the natures of the roots and the relations between the quadratic formula and the discriminant. Okay, so here let's start with the nature of the sorry relationship between discriminant and the nature of roots. Relationship between discriminant and nature of roots. Relationship between discriminant and the nature of roots by the quadratic formula. By the quadratic formula. By the quadratic formula, the roots of the quadratic equations is quadratic equations roots is here ax square plus bx plus c is equal to 0. Okay, these are the standard form of the quadratic equations, and the quadratic equations and the formula will be, since we can say that ax is equal to plus minus b under root b square minus 4ac by 2a. Okay, so this is the quadratic formulas as we know that and plus b square minus 4ac. So this will be sorry here is the plus and the minus, so here it is and also we can say that b square minus 4ac by 4ac is equal to d. So d will always be equal to by 2a. Okay, so by 2a can be considered as this. So discriminant b square minus 4ac by 2a is said to be the discriminant. So we can write here the minus b plus minus under root d by 2a. So it becomes d. So d stand for discriminants. We can say d stand for discriminant. Okay, d is said with the discriminant. So we will study here that d called it is discriminant. So this equal to discriminant, so will be always be b square minus 4ac. Okay, so it can be said that capital D. Okay, so we will study here that if 4ac discriminates the nature of roots nature of roots depend upon the value of b, means that discriminants. So here some conditions involved. So for this one things, so these cases may arises. Okay, d, since d can be positive or negative. Okay, d can be positive or negative. So here, so here the three conditions arises. What three conditions? If d is small or negative, or we can say that if when d is 0, when sorry, case first we will write here when d is equal to 0. Got it? So if d is equal to 0, that is b, that is, it means that b square minus 4ac is equal to 0. Okay, b square minus 4ac will also consider to be the 0. So what we will write here, d is equal to b square minus 4ac. So d is equal to b square minus 4ac, and x is equal to, as we know that this x is equal to plus b plus minus d by 2a. Okay, so here is the plus minus, means that if taking plus or minus, b by 2a, because d becomes 0, so either be plus or minus, it became b by 2a. So here one condition arises that b is d discriminant always be this condition. So these conditions will, we can say the quadratic equations have two equal roots, are are the repeated or coincident roots, means that it have two equal roots are coincident, are three names here comes here. Coincident, two equal roots are repeated roots. Equal roots, incident, coincident are repeated root. So three conditions involved. So for the first case here, in case of first and case of second case arises that. So what does the second case tell us? Second case tell us that when d is less than 0, when d is less than 0, then we can say that b square minus 4ac is equal to anything, means that negatives, anything will be negatives. Okay, so x value will always be negatives. Okay, so d will always be this b square. So d is equal to b square minus 4ac is less than 0. Alright, this conditions arises. So we can say that here always be minus d by 2a. So x is equal to b square minus 4ac by 2a under root b plus minus. So it becomes less than 0, means that it would be something. So d will x is equal to under root b plus minus b under root d by 2a. Okay, in these conditions we can say that it will always be both will be negatives. This becomes and this becomes always be negative. So minus b minus d by 2a. So this condition, so we can find here. And in case of so what does the value says? So value say always here there. So the quadratic equations, so quadratic equations have two distinct real root. two distinct real roots, just like that. And in case of third, what happens if suppose that when d is less than 0, less than 0 means it is greater than 0. So d is less than 0. What happened after if the d is less than 0? Then b square minus 4ac, then b square minus 4ac is less than 0. Okay, so less than 0. So x value, we know that x value, what will be the if it's going to also less than 0, so d cannot be evaluated. Then d can not be evaluated means that it would be imaginary, it cannot be evaluated. So so we can say that not square roots evaluated is their real numbers whose square is here. So equations has means that equations have no real roots or imaginary roots. Okay, no real roots or imaginary roots. We can with the help of that, so we can consider. So quadratic equations for this find discriminants, three conditions arises. Quadratic equations, three conditions. So quadratic equations arises three conditions: first, second, third, on the basis of discriminant d. Okay, for discriminant d, three conditions arises, quadratic conditions. What three conditions that would be? So all conditions would be if d is 0, d is less than d is equal to 0, d is less than 0, and this d is greater than 0. So three conditions arises. This will be if the d is 0, then so roots are real, and that will be roots are real and equals. Here if the roots are real, okay, it's also be real and equal, and the roots are real and distinct, and here is roots are imaginary or no real roots, imaginary or not exist. Okay, no real roots cannot be possible if the d is less than 0. So three conditions arises. We had studied three conditions and understood that's what is the difference between the discriminant and the quadratic equations with quadratic formula. So here we had studied the discriminant and the quadratic formula. So what's the real conditions? Three conditions arises. If the discriminant is 0, discriminant is equal to 0, discriminant is less than 0, discriminant is more than 0. Thank you very much for coming on this channel. Once again, I am telling you that you are learning and you are going to on the path of the progress. Please don't forget to share, subscribe these channels. Okay, bye bye.